In this video series, I work through a math problem or problems each video. For some uniform rate problems, there is something that affects the rate of the object or person in motion. For example, the water in a river could either slow down or speed up the speed of a boat, depending on whether the boat is moving upstream or downstream. Let's take a look at the given problem. A boat can travel 40 miles per hour in still water. If this boat takes 3 hours to travel upstream in a river from a boat shed to a pier, and 2 hours to travel downstream from the pier to the boat shed, find the speed of the water flowing in this river. So let's go ahead and first organize the information into this chart. We know that the rate of the boat is 40 miles per hour. So we can start by writing 40 here, but depending on whether the boat is traveling upstream against the river or downstream with the flow of the water, the rate is going to change. If the boat is traveling upstream, the boat is traveling against the water, so the speed of the water is going to slow down the boat. So if we use the letter R to represent the speed of the water in the river, we need to subtract that from the speed of the boat. When the boat is traveling downstream, the flow of the river will speed up the boat, and the amount or the speed by which the boat is sped up is the speed of the water, which is R. Next, we're told the times that the boat takes to travel the distance between the boat shed and the pier. The time traveling upstream is 3 hours, and the time traveling downstream is 2 hours. We can use the formula rate times time is equal to distance twice to calculate the distances. Since the distance is the same whether the boat is traveling upstream or downstream, since the destination and the starting points essentially are flipped, but they're still the same points. So these distances are equal to each other. So let's write an equation setting these two expressions equal to each other. Next, we can use the distributive property on both sides of the equation to multiply this out. 3 times 40 is equal to 120, and 3 times minus r is minus 3r. This is equal to 2 times 40 is equal to 80, and 2 times r is 2r. We want to get all the terms with r onto one side of the equation and all the numbers onto the other side of the equation. So we can first of all add 3r to both sides, and to move 80 to the other side, we can subtract 80 from both sides. (120 minus 80 is 40, and 2r plus 3r is 5r. Then to solve this equation for r, we can divide both sides of the equation by 5. And since 40 divided by 5 is equal to 8, we found that the speed of the river or speed of the water flowing in this river is 8 miles per hour.